Welcome to our comprehensive guide to Kubernetes. In this video, we'll explore the world of Kubernetes, its origins, key concepts, and why it has become a must-know technology. So let's dive right in. What is Kubernetes and why K8s? Kubernetes, often abbreviated as K8s, is an open-source container orchestration platform. But why the name K8s? Well, it's a bit of nerd humor, where the 8 represents the 8 letters between K and S in Kubernetes. The story of Kubernetes starts with Google's internal container orchestration system Borg. Borg managed thousands of applications within Google and served as the inspiration for Kubernetes. Kubernetes was developed from Google's Borg project, which was open-sourced in 2014. Now let's delve into the core components of Kubernetes. From a high level, a Kubernetes environment consists of a control plane, the master node, a distributed storage system for keeping the cluster state consistent, and a number of cluster nodes, or kubelets. The control plane manages the cluster's state and is often distributed across multiple nodes for high availability. A Kubernetes cluster is a set of machines called nodes that are used to run containerized applications. API server, controller manager, and scheduler are the three main parts of the control plane. For high availability, these services can either share a single master node or run independently on multiple master nodes. The API server acts as the interface between the control plane and the cluster, allowing clients to manage the cluster via a RESTful API. It provides APIs to support lifecycle orchestration, scaling, updates, and so on for different types of applications. The controller manager is a daemon that runs the core control loops, monitors the cluster state, and drives status toward the desired state by implementing changes. The cloud controller manager's integration supports each public cloud, ensuring that availability zones, VM instances, storage services, and network services like DNS, routing, and load balancing are all properly taken care of. The scheduler is in charge of distributing containers across the cluster's nodes, and it must take into account a number of constraints before doing so. These include, but are not limited to, affinity and anti-affinity requirements, resource guarantees, and resource limits. The machines that make up cluster nodes, known as worker nodes, run containers and are overseen by the cluster's master nodes. The kubelet serves as Kubernetes' main controller. In most cases, Docker is the container execution layer that this component controls. Each node hosts pods, which are the smallest deployable units in Kubernetes. Pods are a fundamental unit of understanding in Kubernetes, as they are the primary unit of work for programmers. On the other hand, pods can also host vertically integrated application stacks like the LAMP, Linux, Apache, MySQL, and PHP stack that powers the popular WordPress content management system. A pod represents a running process on a cluster. There are many distinct pod varieties. The default type, replica set, is straightforward. It guarantees that the required number of pods are active. Replica set helps bring up a new instance of a pod when the existing one fails, scale it up when the running instances are not up to the specified number, and scale down or delete pods if another instance with the same label is created. Deployment is a declarative way of managing pods via replica sets, includes rollback and rolling update mechanisms. You can define a deployment to create a replica set or to remove deployments and adopt all their resources with new deployments. A daemon set ensures that each node runs an instance of a pod. As nodes are added to the cluster, pods are added to them. As nodes are removed from the cluster, those pods are garbage collected. Some typical uses of a daemon set are running a cluster, storage daemon, a log collection daemon, or a node monitoring daemon on every node. A stateful set is a controller that helps you deploy and scale groups of Kubernetes pods. When using Kubernetes, most of the time you don't care how your pods are scheduled, but sometimes you care that pods are deployed in order, that they have a persistent storage volume, or that they have a unique stable network identifier across restarts and reschedules. In those cases, stateful sets can help you accomplish your objective. Job and cron. Job runs short-lived jobs as a one-off or on a schedule. Because of this inherent transience, it is difficult to keep track of which pods are available and running a specific app. This is where services can help. Services are a way for Kubernetes to configure a proxy to forward traffic to a group of pods. Services use selectors or labels to define which pods use which service rather than static IP address-based assignments. These dynamic assignments make it extremely simple to release new versions or add pods to a service. When a pod with the same labels as a service is started, it is assigned to the service. We have different types of services. Cluster IP exposes a service that is only accessible from within the cluster. Node port exposes a service via a static port on each node's IP. Load balancer exposes the service via the cloud provider's load balancer. External name maps a service to a predefined external name field by returning a value for the CNAME record. Services are only reachable within the cluster by default using the cluster IP service type. Other service types do allow external access. The most common in cloud deployments is the load balancer type. It will launch a load balancer for each service in the cloud, which can be costly and also become very complex. Kubernetes supports ingress, a high-level abstraction that governs how external users access services running in a Kubernetes cluster via host or URL-based HTTP routing rules. For cluster-wide, pod-to-pod networking, Kubernetes has a distinct networking model. Most of the time, the container network interface employs a simple overlay network to hide the underlying network from the pod via traffic encapsulation. It may also employ a fully routed solution. In both situations, pods communicate using a cluster-wide pod network that a CNI provider manages. Containers in a pod share the same network namespace and an IP address and are free to communicate with one another. Moving from pods to services or from external sources to services necessitates the use of kubeproxy. Kubeproxy handles network traffic routing to pods, providing load balancing and traffic distribution. etcd, a distributed key-value store, stores the cluster's persistent state, making it essential for data storage. Now that we understand Kubernetes, when should you use it? It is all about finding the right balance, as is so often the case in software engineering. The upsides. Kubernetes offers scalability, high availability, self-healing, automatic rollbacks, and portability, making it ideal for managing containerized applications. The downsides. Kubernetes is complex to set up and may be overkill for smaller organizations, both in terms of complexity and cost. A great option for organizations is to leverage managed Kubernetes services offered by cloud providers like Amazon Elastic Kubernetes Service, Google Kubernetes Engine, and Azure Kubernetes Service. These services handle the heavy lifting, allowing you to focus on your applications. Let's talk about how it can benefit microservice architecture. But first, I would appreciate it if you could subscribe to the channel and give the video a thumbs up and help the channel scale. Talking about scalability, one of the key benefits of Kubernetes for microservices is its scalability. With Kubernetes, you can easily scale your microservices up or down based on demand. This means that as your application grows and more users access your microservices, Kubernetes can automatically handle the increased workload by deploying additional instances of your microservices. High availability. Kubernetes also provides high availability for microservices. By distributing your microservices across multiple worker nodes, Kubernetes ensures that even if one node fails, your microservices remain accessible and the overall system continues to function. This fault-tolerant approach helps minimize downtime and ensures a reliable experience for your users. Load balancing. Kubernetes offers built-in load balancing capabilities, which are crucial for microservice architecture. With load balancing, Kubernetes evenly distributes incoming traffic across different instances of your microservices, ensuring optimal performance and preventing any single instance from becoming overwhelmed. This helps maintain a smooth and responsive experience for your users. Easy deployment and rollbacks. Managing deployments and rollbacks can be complex in a microservices environment. However, Kubernetes simplifies this process by providing easy deployment and rollback mechanisms. You can easily deploy new versions of your microservices, monitor their performance, and roll back to a previous version if any issues arise. This flexibility allows for seamless updates and reduces the risk of downtime during deployments. service discovery, and communication. Microservices often need to communicate with each other, and Kubernetes provides a built-in service discovery mechanism to facilitate this communication. With Kubernetes, you can easily discover and connect to other microservices within your cluster, making it easier to build and maintain complex microservice architectures. Monitoring and auto-scaling. Kubernetes offers robust monitoring and auto-scaling capabilities, which are crucial for microservices. You can set up monitoring tools to track the performance and health of your microservices, and based on predefined metrics, Kubernetes can automatically scale your microservices up or down to ensure optimal resource utilization and maintain performance under varying workloads. In conclusion, Kubernetes provides a range of benefits for microservice architecture. By leveraging Kubernetes, you can effectively manage and scale your microservices, providing a flexible and reliable architecture for your applications. Kubernetes is a powerful tool for container orchestration, offering both great capabilities and challenges. Whether you dive in or opt for a managed service, understanding Kubernetes is a valuable skill for modern software engineering. Thanks for joining us on this Kubernetes journey. If you found this video helpful, please like and share it. If you have any questions or topics you'd like us to cover, drop them in the comments below. See you in the next video.